Now let's doing last video I tried to make today. So let's quickly get into it. Let's construct string with minimum cost. So you are given a string target, an array of string word, and an integer array cost. Both array of the same length. Okay, the image an empty string as you can perform the following operation any number of times. Okay, now can see a pane. Now what I2s the cost of operation is cost I. The return minimum cost to make as equal to target. If it's not possible, return -1. Okay, so any question you see in minimal maximum cost, you just first idea is dynamic array, dynamic programming. You can use this way. Now let's see the example. It's the target, right? A, B, C, D, E, F. It's word array. Here, this word costs 100. A, B, C costs 1. D costs 1. 10 costs this DF costs 10. EF costs 5. Now here's explanation. The minimum cost can be achieved by performing the following operations. Select index 1 and append ABC to S at the cost of 1, resulting in SABC, and select index 2 and appending D to the X and cost of 1. So ABCD. Okay, ABCD now, resulting in the ABCD, the state index 4. So here we just find the minimum cost, right? It's not hard to understand. So now how to implement this coding. So now let's go through how I solve this question. So solving this question, we can use the try. I'm not sure, do you know the try? Try is kind of like for the searching. All we call the try is dictionary. And then plus the DP, dynamic programming. So we this question we must be using these two structure to solve it. Now let's quickly go through this one. So how I'm not sure, do you know try? Try is like you have one node and node have 26 later. The 26 later you can understand it's lowercase later, right? A, B, C, D, E, F, G, right? Now, yeah, we just use this way. Now we can quickly go through this one. So we have the A, B, D, E, F. So I create here A, B, D, E, F. We have this path, right? So this path costs 100. But we know, okay, A, B, C, D, E, F. We know here we already finished the first 5 later. But we still have F, right? Still have F left. Now the problem is we couldn't find F in this register word array, right? So this one is not what is not reaching the last character. So I would say just skip. Now we need to try the second slide in the second word. So we can see here A, B, C. So we know A, B, C. So we already finished the first 3 later, right? So ABC costs 1. So now we just 1 plus. And then now we need to start from D. So let's see. We have D, E, F, and the EF. So let us try the here D. So now D here the D costs 1, right? 1. Now we finished the D. Now pointer point to E. So now we will check the tree. We call this one try. Okay, we find we have E, F. Okay, we find it. Why we have EF from here, right? Because I use this word to create a tree, create a try. So we got the EF. Now EF5. Okay. So here we got a 7. But because we first start from here, right? But we don't know is the minimum. We don't know 7 is the minimum, right? So we still need to keep processing the other permutation. So naturally here we need to use the dynamic programming. So sometimes if you want to do some permutation, you can use backtracking or dynamic programming. But here we need to use the dynamic programming. So now we know we just start from here, right? A, B, C. So if we start from D, let's see what happened here. Now let me okay. Call this up. Now we start from D, E. We have D, F, right? D, we find D, E, F. So we check the F. It should be 10. So now it's 1. No, it's 10. Okay, now we finish the DF. We already reached the end. So A, B, C, and D, E, F. So 1 plus 10 equal to 11. So 11 comparing to the current minimum cost. So 7 still minimum, right? So now we finish D. We need to check EF, just permutation. So now, and here also one possible we need to take care of. 1 second. Let me erase this out. So it's happened maybe in the example have duplicate with a different cost. So you can see here we have ABC. Oh no, maybe I use DEF. Maybe we have 2 DEF. So now 2DF, the second DF, the cost maybe 1. So we know the DEF go this pass, right? This one. So when we create the first pass DF, so here we will enter F with the 10 cost. Yeah. Now when we try to go through the second DF, now we also go this path, and then we know here already have 10. So but the current DF have cost 1, so we need to compare which one is smaller. So we know 1 is smaller, right? So here do one thing, we just remove the 10 and we just use the 1. We just update 1. This path only cost 1. So yeah, it may happen in our test case. So we need to take care of this one. And then let me see, do we have any edge case we need to consider? I already covered. So if we finish each word in last character, we need to provide the okay, this one is n, so we can use the boolean word boolean to present this one is n. We need to start here, and also in here in this level we need to provide the cost so they can easy to follow. And then we use the dynamic programming to go through each potential potential permutation and combination to find the minimum cost. So now let's code it up. Before coding out, we need to create a node class. We need to create a try and a boolean, and then we need to know because here have we call children. Now we need to create a constructor. And now we need to children with size node 26, right? We know each where 26 node. Each node is from A, B, C, D, E, F. Now, so the cost equal to -1, and then now we can start do some build a try. So a word. So here we need to pass the what ORD, right? We need to receive each word and with the cost. And that should be. So now we need to create the root. We always start from the initial root. Now we need to go through this word. And the word length. Oh. So now we need to do one thing. We need to know the index. So is A, we know A represent 97. So we need to know the and the I minus A. So we will get an index. Now next step, we need to check the root.child index equal to null or not. If yes, we need to create a null. Now, oh wait, okay. Now we need to go to next node. So root.children.index. So now if this we already finished the what the path, right? We finish A, B, C, D, E, F. If we break the for loop, which means we already reached the end, right? So we need to do one thing, which need to map the current node. The current node is n, right? So here we can use the 2, and then we need to provide the root.cost. If -1, which means it never be initialized, never be assigned particular cost, right? So we need to root.cost equal to passing cost, right? So it still has duplicate I mentioned before. So we need to find the minimum one, right? In the so it's the cost, right? So we need to find which one is smaller. So we finish the build the tree. Now here we need to do now here we need to do the search. The search mean is dynamic programming. So here we can first finish here. We need to create a root object because we need to call this a word and our search method. A word method. So here we need to create an object first. A name we need to okay. And then we need to go through. We need to build a tree, right? We need to pass in the word and the cost. So here, prime I equal to 0. The word. So we need to add root.add word partner I the cos I. Here we pass this one to build a tree, and then we need you create the meaning cost A. Or you can call this like DP, because we use this array to find the minimum cost. And now here's length is the target length. Right. Now we need to array the field, the mean cost. Make it 1. So now here we need to call the root search. So we need to pass the array. We need to pass the target. We need to pass the meaning cost. And we need to pass in there. And then finally we just return. So mean cost, right? So it's kind of like is bottom up. Now here we have the reach method. Now we need to finish here. After here. Now here we need to pass the public. So here public. So we need to return in search, right? And now first one is word. First one is target. The second one is array. Okay. And the mean cost, right? And the second one is parameter is integer index. Now we need to check if the index equal to target. So which means we're reaching the end of target. We reaching the end, right, of target. So now we here return 0. If mean cost dot index not equal to 0, -1. So which means why you here? Because it's kind of like caching. So we don't want to do repeated processing, right? It's waiting our time because we already get the processing. We already get the cost. So we don't need to do 1 more time, 2 more time, right? Wasting our time. So they will reduce the time capacity. So here that's why we just directly return in the index. Also its length. So okay, now we need to do one thing is no root the list, right? Now we need to do one thing. We need to go through this target. Target the length. So here is not I, it's index. Otherwise it will be repeated. Always start from first one. It's not make sense. So it should be start from index. Now we need to do one thing. Partition. And here do the same thing. Is chart I and -a. We gonna partition, and then if root dot children equal to no, okay, which means we cannot find the path, right? So here we need to directly return, or we say it's break. We need to break this one. Okay, root. We need to go to next children. Root dot children dot partition. So now you finish this one. So which means now here we need to check the loop that is n. We need to check it's true or not. If yes, if it's true, so we need to call use next word. now we need to read. Okay, now we need to search, right? Search in, okay, it's target. The minimum cost here should be I plus 1 because we need to go to next word. Maybe we finish, for example, ABC, we finish one. So now we need to use the next word and the finish this word. Now here, we need to check if the raise equal to -1, so which means we need to continue. Continue. Now here we need to do one thing. If not, this statement never get executed, which means we need to min cost index -1. So we need to assign the result and the current cost. So meaning cost and one second. So okay, sorry, here should be inside the here. Now we can do, because if minimum cost index -1, so we here need to be plus the root.cost, right? And if here this one is not the min, if it's already assigned something there, so we need to do we need to update. We need to do comparing, right? So here the min cost and the index, we need to find the minimum one. So min cost index over the root.cost plus the risk. So we need to check which one is smaller, right? And then, so here we need to return min cost, right? So now I think I finish this one. Okay, you can see it's passed on the test case. Now let me submit it. Oh, okay, it's time limit. So let me check. So here's index cost, root.cost here. So if here -1. Okay, now here continue rest. So so if index equal to target down length equal to 0, if the minimum cost index not equal to -1, so return the minimum index. Yeah, so you root that list equal to index. So I purpose the position, we got the position. Now if children position equal to no, which is break. Yes, sync right here. And root equal to, yeah, we'll go to next position, next node, right? Now wrong here, so it should be something wrong here. Right, cost and children, I initialize here. It costs -1. Now here's loop. Here, loop that children equal to no, and loop that children in there equal to no, loop equal to, okay, it's good. Now if we finish this one, we say this n equal to 2, and loop equal to -1, and cost, okay, look at the minimum cost, that cost, okay. So it should be error here. For I equal to 0, then I plus, and the root at what? Tagging length and the array that field mean cost -1. So mean cost here, field cost